Hello everyone and welcome to my video. My name is Ewing Singer and today I will be demonstrating the Ishima Link Logistic API with a focus on security and compliance features. So as you know, this Formative tool is built on the core architecture from our Formative 1. So today I will show three critical security implementation, which are the rate limiting to prevent like false attacks to your account, the field level encryption for sensitive data, and how the API handles authentication. So now let's get started. Now before we get started, let's start our server. So now let's just wait for our server to start and run. Okay, now our server is running. So let's get started now. So first, let's demonstrate rate limiting. So we're using Postman, which is a tool for testing APIs, and now the rate limiting is a security feature that prevents attackers from making like too many attempts, login attempts in a short time to your account. So here I have the post request set up to the login endpoint, and we'll have our link. Now we're gonna use like let's say as we have our username and we'll have a password. Now we'll intentionally use like wrong credentials like the username admin, which I've created an account with, but I will use intentionally use a wrong password. Let's just not look too far. Wrong password. Yeah. So now this will trigger like failed login attempts, and the API is configured to allow a maximum of six failed attempts per minute. And on the sixth one, the attempts will return a 429 error. So now let's send. Yeah, first one, 401 and auto rest, which say invalid credential. Now let's do it six more time. Again, 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 again. Exactly. So now I've made like multiple failed login attempt. And first one, we saw that each one returns 401 and auto raise. And now on the sixth attempt, we've seen that we've got 429 attempts, which takes too many requests error. Now the API blocks the further login attempts for 1 minute. This is rate limiting in action. It's a critical security feature that prevents brute force attacks, where attackers try like thousands of password combinations. So without this, an attacker could potentially like guess your credential through automated and tabs really fast. So thank you very much for this first step. Now let's go to the next one, which is the encryption. So now let's look at encryption, and I'm using the DB browser for SQLite, which allows us to view the actual database. And here you can see the core user table with all the user records. Now you can notice the national ID column. This is where we store the random national ID number. So now if we get to the browse data, now here you can look at the encrypted data in the national in the ID column. We have this. It contains random looking characters. This is I think this is called the Frenet. Yeah, the Frenet encryption. Um, this like this data is completely unreadable by other people in the database. So even if someone gains unauthorized access to the database file, they cannot read sensitive information like the national ID without the encryption key. So this is it. Um, this it's I think it's a 444. Yeah, it's a 44 character key. Like this, that's exactly why it makes the for other people to read it impossible. So without this key, the encrypted data is useless, honestly. So in prediction, this key like will be stored in a secure environment variable or secret manager, yeah, but never in the code. So yeah, the encryption happens transparently. When I say that is like when data is saved to the database, the encrypted field automatically encrypt using Fairnets, the one I told you about. So when data is retrieved, it's automatically decrypted. So this means developer don't have to worry about encryption. Like it's handled at, let's say, at the model level. Yeah, this is the best practice for like protective sensitive data. This is what I've learned. That you can see here using the encrypt and decrypt method. So now let me show you the code behind these security features. Now here in our authview.py, like you can see the rate limiting is implemented using a decorator. So like the rates limit decorator like limits login at times to 5. No, we use 6 to 6 per minute uh, per IP address. So this is a simple, but I think it's effective. Like it's the most effective way to add rate limiting to any endpoints. And here's the encryption implementation in our encrypted dash fields.py. So the encrypted field class like extends Django's and adds like automatic encryption and decryption. So when you save a user with a national ID, it gets encrypted, and when you retrieve it, sorry, it gets decrypted. So this is transparent to the rest of the application. So to summarize, I've demonstrated like the three critical security features we will ask for the Ishima Link API: the rate limiting, the field level encryption, and the secure authentication. So this feature like works together to create, let's say, a secure way on the platform. So the code is well documented as you noticed and you asked for. It's type annotated and follow the Django best practices, which I've learned during this process and I wish to learn more. So this implementation satisfy all the requirements that we will ask about the security features of this application. Thank you very much for watching the video.